Okay, let's do another interesting task with projectile motion. So here is the simulation I showed you earlier. I want you to use it again. Go to the link and go to the lab, and then you can try to adjust different parameters. So what I want you to find is, imagine you can adjust the angle without changing anything else, without the presence of air resistance. What it could be the angle for the longest range. So as in for the range, it means horizontal displacement, so how far basically you can shoot, so what angle it should be. So I'll give you some time, try to also write down how you can conduct the experiments as well, and what do you find out at the end, what the angle it is.
A few moments later, a few inches later, 2 hours later, 1 eternity later.
Okay, so let's take a look. The experiment in Excel is actually very simple. What you could do is, apparently you can try to change different angle. Of course, you can do more regularly than I do, and in fact you should find 45 should be the one go with the longest range, and then you can see the other angles are basically giving you a shorter angle. Okay, and the other thing that you may want to find out, okay, so basically the answer is 45. The other thing that you may find out is, interestingly, is that if you look for angle, say 50, okay, so this is the point where it lands, and since you know 45 is the longest from its simulation, at the same time, if you try 40, interestingly, you'll find they land at the same angle. So this could also be another challenging question that you can try yourself. So how to prove in this relationship? Apparently the relationship is, if you shoot with a certain angle, say theta, then it will be the same range as in you shoot it with 90 minus theta. I'll give you another example. Say if it is 25, this is the range to this point, so 90 minus 25 should be 65, and you can see it's the same point. Okay, so this could be another question, but then for today, I mean, in this video we would only focus on how come 45. So 45 here is the longest range, so you would want to prove it in terms of the equation that you learned. So again, I'll give you some time, try to pause the video and do it first. Okay, so the proof is actually not easy. What you have to consider is you have to think about differentiation as well. So this comes into handy as in when you learn about calculus, then it helps you understand physics a bit more. Of course, the things that we are doing now is not really in the IB syllabus, but I just feel it is interesting and I would like to share with you. I mean, ultimately, it's not only for exam, but understanding more about the nature of the world. So in order to prove 45 is the so-called the best angle for launching for a longest range, then you need to probably find the range over the theta is 0. This is if you learn differentiation, you know when you have a rate change of this as the turning point, then this is either at a certain angle, then this must be at either maximum or minimum. Okay, so firstly we have to find the expression for the range first, and then we have to differentiate it with respect to theta. So let's try it now. Sx is what we want to find, and then we have a certain velocity u, and then it will give you u y as in u y as in sine x, sorry, sine theta. Ux will be u cosine theta. Acceleration will simply be g, and in order to find the range, let's call range as r. So range will simply be ux times t, which is u cosine theta times t. And so we apparently have to find the expression for t, and since t is changing, right, because u is a constant, so when you differentiate, you don't have to really care about this. And so in order to find t, then you need to think about the things that you have. That is, for vertical, you have u sine theta, acceleration equal to g, and t is the unknown. And one more thing you want to find is, in our situation, we set, well, actually one thing that we actually assume, I didn't mention, is you are on the same level on the ground. So you may have set up the cannonball, like rock, like this thing, this, how do you call this, launcher, should I say, above the ground. You can do that, but then in that case, then I think that may change the angle. It may not be 45. You can try to check it out by yourself. Again, that could be another interesting investigation you can try. So then based on that, then we could say sy is 0, right? So sx is basically the range. So in fact, why don't we just say sx like this? So for this, sorry, it's a bit messy, but then now I'm doing vertical. Then you could use the equation s equal to ut plus half at squared, with sy to be 0, u to be u sine theta, t plus half g, t is the unknown. And so this come into a tricky issue where you have to express t without knowing the exact number for this. This is basically a quadratic equation. So from what you learn in maths, you should be able to find the roots of this quadratic equation, as in either, well, actually you can just take it out. Yeah, it's not that difficult, because you don't have constant, right? Constant is 0. So basically you can say t could either be 0, or you can solve the equation as in u sine theta equals to negative, actually, half gt. So t equals to 2 negative u sine theta over g. Yes, I think that is what you could find. And then after you find this, apparently 0 is not the one that you want to use, and that would be this instead. So for this one, then you could substitute back into this equation, and then you can get u cosine negative 2u sine theta over g. And so in that case, the expression could be simplified as in, for the range, it could be negative 2 u square, sorry, I forgot the theta here, sine theta cosine theta over g. And one interesting thing that you should find in maths is that you have learned something called the double angle, and that is sine theta cosine theta times 2 actually equals to equals to sine 2 theta. Okay, like this. Alright, over g. So ultimately, when you try to differentiate it, allow me to do it here, because I don't have space. So when you try to differentiate the range, which is dsx over d theta, then that means you are differentiating negative u square sine 2 theta over g with respect to theta. And you should realize that negative u squared and g are constant, so you can actually take it out while you just differentiate sine 2 theta. And if you learn about calculus in maths, you should know it is going to be 2 cosine 2 theta. Okay, and that is simply the expression for d sine x over d theta. And as we said, we want to find when it is 0. So when d sine x, sx over d theta equals to 0, then apparently all these things here would not actually matter because they are not 0. So it's only when cosine 2 theta equals to 0, and that is when cosine, think about what angle is this for cosine to be 0, and that means 2 theta equals to 90, and therefore theta is 45 degree. And so here is the answer, that how you can prove under this situation the angle where it gives you the longest range is 45 degree. And I hope you enjoy using the differentiation throughout this process. And yeah, I think this is how mathematics and physics can work together and give you a really nice result. And this could be something that I mean, I'm not saying that you use this as a topic for your IA, but then in IA, differentiation or integration could be something that you use, and often is something that you could use to kind of show off your math skills at the same time your personal engagement onto the topic. Okay, in case any of you tell me you don't actually understand or have learned anything to do with calculus, I can show you another way. It's also quite simple. So all the proof that we did here does not require differentiation, right? So you should be able to get the expression of Sx equals to this, all right? But of course you have to know the double angle formula from trigonometry. Then think about this. Since this is a range, and you can see this is a constant, only angle here is a variable. So think about this. For any kind of sine function, the range is actually +1 to -1, all right? And if you think about the absolute value, then it will be 1 to 0. Oh, I should write equal sign as well. And so what could it be to make the range to be the largest, right? To be largest. And that means you have to make the sine function here to equal to 1. So it's the same idea where you, in this case, then you need to make the angle inside the whole thing, 2 theta here, to be 90 degree. And so in that case, again, theta will be 45 degree. Okay, so it's the same idea as actually what we did here, and that would not require you any differentiation.